So, very welcome to this session about European infrastructures from fundamental science to industrial applications. And just to remind you that this session is actually, this first session is part one of the total two sessions. So there will be another session after lunch. So we're having in a rather long period or so, but we have a lot of different panelists that will participate and give us different perspectives of the necessities and the way European infrastructures are really important in order to be able to go from a basic idea, low theoretical fundamental science, into the industrial applications. What are the measures that one can do, and what are the bottlenecks? And we hope it will be a lively discussion. So to kick this off, we will have one presentation now in the morning and another presentation in the afternoon. So in this presentation now in the morning, we are very happy to have Bertrand Fillon with us, who will give a perspective of what this is all about. And just to say some few words about Bertrand. Bertrand has been heavily involved now in the work on the Advanced Materials Initiative 2030 that I'm also very heavily involved in. So we've been working a lot about that. But Bertrand is currently the chairman of the European Composite Plastics and Polymer Processing Platform, the so-called ECP4, and represent EUPC, the European Plastic Converters, in the ECP4 board. He is also the head at the scientific committee of the French polymer cluster Policymakers and the French Plastic Institute IPC. He is a scientific advisor of the French Polymer Group and of the CRIT MDTS in France, which I don't really know what that is, but maybe he will explain. He has a number of technical publications, books, co-author, and patents in the field of polymer packaging and processes. So with this, I give the word over to Bertrand to give an introduction.
Thank you very much, Lars, for this introduction. And CRIT MDTS, it's a cluster of SMEs who work on, I would say, technical surfaces and so on. So this way. Okay, so thanks for this invitation. And I will try to introduce this roundtable to explain what we are doing today in infrastructure and how it works in Europe. So I will split my introduction in three items. The first is a kind of a reminder. What I will explain, you well know, but it's good to remind what's going on, and we are still struggling. And after, I will give you different EU initiatives concerning infrastructure. There is a lot of initiatives. I will give some example, but there is a lot more. And at the end, try to give a kind of a conclusion, but it will be not a conclusion. It will be an open door for the round table. So first, you know this figure. I think yesterday you have seen it, and we know it since few months now, and thanks to EMI 2030 to build up this figure. That's the trip of the idea towards innovation. We start always from, I will say, the blue sky research. You have always a guy doing a blue sky ideas and say, okay, oh, looks good. We need to move up. And the long trip starts from the maturity of science. We start from the idea, we move up with a lab scale, you move up towards, you know, the pilot scale and so on and so on. That's the TRL scale, the maturity scale, from 1 to 8. And if you win, you go on the market, but you must win. And that's a long trip. And at the end, you have the innovation towards different kind of market. Could be packaging, could be energy, could be transport, everything. So that's the trip. But it's a technical trip inside this figure. But you have different parameters. If you want to start with a material, for example, you need a process. Without process, you do nothing with the material if you want a product. So you are obliged to interact material and product and process together. And that's the basic story of a product or a system. But process is not the only parameter. You have other. Circularity is crucial today. When you develop something, you must be sustainable. And you need to think at the beginning of the story, how I will produce my system, my product to be sustainable. What will be the second life of this product? So we need to think at the beginning, from the idea. And the design is the same thing. If you want to have something sustainable to be, I will say, used for the market, you need to design. So you need to think already at the beginning of the story, the design. And today we have the chance to have the GTO technology. 20 years ago we still have, but the performance was different. Today we have AI, we have a lot of kind of GTO technologies, and these technologies are very useful to go faster and to do the development faster. So that's another parameter we need to take in the story. And at the end, you need to be sure the people, the citizen, will accept this innovation. We need to think, and not at the end, since the beginning, to be sure that what you want to develop will be useful for the people, but will be accepted for the people. So that means this story could be a long story. So that means we need to have a new form of inclusive cooperation across the entire value chain. It's crucial to overcome the today fragmentation of R&D, because we have too much fragmentation today. Many times people develop the materials, but they don't integrate already the value chain, the end user. Well, it's someone, but not every time. We need to build up a team, a strong European team, whatever the product you develop. And for this, you need a systemic approach to do this. To be sure you are faster, you will be scalable, you will be efficient in the instrument. So because we have huge challenge, and today the challenge is to strengthen Europe, to have a good economical value and environmental value for today and for the future. So that's the beginning of the story. Now, if you look, that's the linear approach. We know this one, from TRL1 to TRL9, and from the ID. And many times we struggle here, between 4, 5, 6. That's the big story here. Because we move from the lab scale, everything is nice here. You have some modelization, so on, lab scale, always successful. But sometimes people want to jump from year to year. Wow! Big surprise and failure. That means you need something here. You need to have some pilot scale to move from some output to another output, industrial output. So the pilot, it's a good instrument to do this. The technology infrastructure. But if you look, this we know since few years, this famous valley of death. You have still the science here, and people, it's very crucial because you need to understand. You need to understand the basic physics of your product, of your materials at the beginning. Here you have Tetra Pak plant. I think when Tetra Pak build up their packaging, at the beginning they have a look how will be the adhesion between aluminum and plastic, how will be the adhesion between the plastic and the paper. They must understand this to be sure today they are able to run at 600 meters, and they are still progressing. Why? Because they have this fundamental science behind this. So they know what are the basic physics, basic chemics to move up. So when you are here, people are mainly successful. And here it's the nightmare. Because you have the pilot scale, and you need to have this pilot scale. You need to have this pilot machine. And when you want this, you need money. It's a cost. And sometimes it's a high cost. So that's also the crucial part of the game. It's not only a technical part, it's money, the financing part. And when you succeed here, the journey is not finished. You need to jump in the manufacturing. So, and to move from year to year, you need to be sure your technology is reliable, repeatable, the basic stuff, to be sure when you move to the company, you will succeed. So, as I said, the money is a big partner of the story. And here, many times, you have the public funding. And here, of course, it's more the private funding. And in this part, you need to be sure people will be online on time. Because many times you are ready, but these guys are not ready. And you waste time again, because the money doesn't fit at the good time. You are ready on technology, but you are not ready of the funding. So that's this big parameter, and that's crucial parameter. So when I say at the beginning, the value chain need to be aligned. The value chain must be aligned with the policy. Every people, it's a team who will win. All the actors must be aligned at the beginning of the story. Here I give you an example to show it's not a game in 1-2 years. It's a long, long time. I pick up an example of a development done in CA in a few years ago. It was the heterojunction solar cell development. The idea came up around 2008. You know, heterojunction, it's a technology to be better on silicon technologies. And they start with a European project at sea. And you could see the TRL scale. They move up to 3 to 5. And they jump to another one, thanks to the Europe Commission, 5 to 6. And in this case, we start to have industry as a player. So here we have some industrial guys. They are watching, oh, interesting. And after they are more watching, they are work page leader and so on. And after they start to be coordinator, because the technology is moving more on TRL, and the leadership of the industry is very important. So, but of course, behind this, you have other projects with other team, you know. IMEC, of course, IMEC are working on, but we work very closely to them because you have different technologies. So it's very important to share, to be sure every people will work together to have a European technology at the end, a winning European technology. But if you look time scale, it's at least 10 years. So we need to think this. And if you look all innovation today, it's 10 years from idea to innovation and even more. So, and of course we could do faster, but we need to align. We need to use all the instruments we have in mind. So if I wrap up what I say, R&D activity are not a straightforward. No, you see, you have always bottlenecks, nightmare, technical one, financing one, everything. Decision making is very important. You see the curve before. It's very important to be sure people are aligned from the policy to the industry. Innovation policy is good, shift more and more towards the valorization. If you look long time ago, it was, oh, nice research. No, now we need to think business, you know, already. Industry is the center of the growth model. You need to have industry involved. And the earlier it's the best, because you prepare this funding, this investment you need in the future. And pilot line, research infrastructure, technological research infrastructure are key instruments to accelerate, to go through this death valley. So that's crucial. Now I will give you some example of initiative, because there is a lot of initiative at European level to help this. First, you know this one. I think yesterday you have the presentation, that I'm sure, the presentation of the graphene. And this team built up on pilot line, you know, the 2D experimental pilot line project. It was a European project again, aims to establish a European ecosystem for the 2D integration. And their goal was to develop a technology for prototype production of graphene for electronic application, photonic sensors. I want to go in detail because yesterday you have the presentation already. But you have different pilot line from VTT, IMEC, HEMO. And the goal was to have this different pilot line and to share their competency, to share their innovation, and to help SMEs to make development. And that's very important, this. And if you look at how it was organized, how it is organized, you have always this basic line with VTT, IMEC, and HEMO, and they have different line, different pilot line. But the SMEs like to do tests in the 3 pilot line because it's like a plant, like industry. You have different production line, but sometimes the production line doesn't produce the same thing. Pilot line is the same thing. You need to test to be sure that the repeatability, reliability will be good. That's a crucial point, And so they work, and you could see on the top this value chain with different players. So that's show with a pilot line, when people want to share together, you could help SMEs for the development, even large company. Another kind of initiatives done by DigiConnect, the Digital Innovation Hub. Here, this instrument has been developed to help SMEs to move up to the digitalization. And they organize as they launch calls, with different RTO, university, and even SMEs who launch call because they have facilities, pilot line, to help SMEs to produce a product, to make tests and validate the product. And main goal was to digitalize the approach. So they have the role to move, they have the role to move from TRL 4 to 7, this Death Valley. They have a cascade funding approach, and it's a kind of a stop-shop approach to move towards the market. They have successful story. Here it's done by Smarties. It was a hub smart delimited Smarties, and here it's a company, SMEs, based in Dresden, and they develop, thanks to Smarties, a product available on the market. It's a lighting product based on organic electronics, and today they are able to offer this on the market. Thanks to this different pilot line, thanks to this different RTO able to offer the pilot line to this industry, to these SMEs. So after, because these different digital innovation hubs, you have, if I remember well, there are 14, and what they did at the end of H 2020, they have a CSA to share their, I will say, kind of a recommendation. And what they learn, they say we need to have a reference model to be sure we have a kind of a method to define a customer journey, to be sure that when a customer, many times is SMEs, they know what will be happen in the future. They need to also to leverage a common marketplace, because it's always the same thing. You need to have organization. Who are the pilot line? Where are they located? So they need to offer this. They need to align the marketplace to define a standard ontology and categorization for the different marketplace. That's very important to speak the same language, to have the same language, whatever the RTO, to facilitate, I will say, the understanding of the SMEs. And of course, they need to make life of SME easier. That's very important, because when you look, you are SMEs, when you look this European landscape, you are many times afraid, So that's very important to be simple, to keep it simple. And today we have a new approach. It's a progress. It's this European Digital Innovation Hub industry. So it's a group of actors, but here, SMEs are very good at regional level. So they are focused at regional level. It's the same approach like the Digital Innovation Hub, but here, many times, it's supported by different European clusters. And I will give you an example of a European cluster who leads this. And they must offer 4 types of approach. Of course, they need to offer innovation ecosystem networking, like we have seen before in the hub. They need to offer the test before investment, because SME have not so many money, and we know the money is very crucial for the future. So it's very important to have these facilities around you and make tests and this network. They need to support to find investment, because SME don't know how to find the investment, and this network will help. And of course, at the end, to improve the skills and training. So that's the 4 pillars useful for this different kind of innovation hub. Here is an example. Polytronics, they just started up a few months ago, is coming from Polymeris, a French polymer cluster, and they have these 4 pillars to help SMEs. They just kick off, and they will use, of course, this digital transformation, AI, to help SMEs to do innovation. So that's the 4 pillars, and you could see the test before investment. That's crucial. And this training for the different company collaborators, training to improve, support for the investment, because the cluster are very linked with the region, so they could help the SMEs to move towards the policymakers in the region to help for the investment. And of course, if the SMEs want to grow up at European level, they have this network. So the cluster could help to find another SMEs, the value chain, to another, I will say, region in France or in Germany or whatever, to help the SME to grow up. Another initiative, you know this one, OITB, and you have different kind of a project on OITB, Open Innovation Test Bed. It's the same kind of concept. It's a network of interconnected solution provider. So, same thing that we have seen before. Digitalization is less, but you know, without digitalization today, you could be stressful. So it's very important to think about this digitalization. And they must offer access to demonstration, upscaling facilities, as well as services. And they must gather all relevant players, because it's not only one technology who will succeed, it's a mix of technologies. I give you another example. Tetra Pak will be not happy to see such a package, the Doi Pack. So here it's a Capri Sun, you know, this famous drink, and the single entry point was the Fraunhofer, and Capri Sun gave them this, I will say, requirement. We want a very strong gas barrier. We like to have a simple assembling, and we want to be 100% recyclable. So what did, thanks to the ITB, because Fraunhofer have a specific pilot line, IPC have a pilot line for recycling, Fraunhofer, FEP have a pilot line for the barrier properties to make deposition of high barrier, and you could see Quatema here, it's a machine producer, and they are able to deliver some assembly line, and Amcor is the final end user who produce the product, you know, and Capri Sun will launch this with a drink at the end. So you have the value chain here, and you have different pilot lines. So it was very successful because you have all the key players, the value chain, and all the different pilot lines to help to move towards these different bottlenecks. And at the end, also, IPC publish a recognition of certification for the recycling. So that's very important, because at the end, we need to show this product, this packaging will be recycling 100% for the future. So thanks to this OITB project, and there is some key success factor, like the two-side value proposition, a single contact point. So Capri Sun is not SMEs, but if you have SMEs, it's very good to have a single entry point. A slim structure, you could see, they are not a big team. They are 8, 6, and it's very good because you could faster. But there is some barrier. Many times, the legal structure is different. And this could give you some bottlenecks to develop faster, because legal guys discuss together, and we start to be a nightmare. And the collaboration versus competition. But you see, Fraunhofer like to get this for them, IPC like to get this for them. We must break down all these barriers. If we want a strong Europe, we need to share. It's not the winner at the end will be a team. It will be not Fraunhofer, it will be not CA or IPC or whatever. It's a team. The competition is not in Europe. The competition is outside Europe, China, US, and everything. We need to be careful with it. We need to work as a team. Think globally, I will say. Okay, so as a conclusion and to give some idea for the discussion in the round table, last year GRC published a very nice booklet on infrastructure. If you have not read it, please read it. Very interesting ideas behind this. And what I did, I pick up some ideas, and I pick up these ideas based on what I said before. Technology infrastructure landscape are very diverse, and we have seen this before. You know, they are everywhere. And for large companies, an easy game because they are very involved in European affairs and they know where it is and so on. For an SMEs, it's tough. Where are we? So it's very difficult, and we need to simplify this. We need to have a good mapping. There is some mapping. In nanotechnology, I know we try to build up some mapping, but we need to find a way to simplify this. Technology infrastructure play an essential role to facilitate technology transfer. That's very important. From the basic research to market, we have this Death Valley, and the pilot line are crucial to jump this Death Valley. Technology infrastructure build bridge across discipline. You have seen we have different disciplines, and that's very important to have different type of technological infrastructure to jump over this, and to be sure that we address the societal, environmental, and industrial challenges. Research infrastructure, because there is a lot, and in Grenoble we have the synchrotron and so on, and they are very useful because with this research infrastructure you have the basic understanding, and you need always them. I will give you an example I did in CA a few years ago. For the fuel cells, the membrane are crucial, you know, the membrane. And thanks to the synchrotron in Grenoble, to understand the aging of the membrane with the water, you know. And at this time, we were at TRL 5, 6. So we were not at TRL 1 or 2. We did basic research to understand how the water, I will say, interact with the membrane and interact for the aging of the membrane. And we were at TRL 6, 7 because we are in the pilot scale and we have seen, wow, what happens in the aging? It's very strange. And thanks to the synchrotron, because we did very interesting experiment and he helped us a lot to move forward. So research and technology infrastructure are two important elements for the ecosystem, you know. And both play together as a synergy. And we need also to ensure, because it's nice to have technological infrastructure, but technology progress every year. You need to invest, you need to upgrade. That's very important. It makes no sense to have a nice machine and 10 years after the machine is the same. No, you need to upgrade, continuously upgrade. And in that case, we need to think how to get the funding. And I use this last slide we built up a few years ago with the CSA, but I think it's still update. You could see where is the Death Valley, and you have the cost curve, and we know the cost curve start with a pilot line, and after, when the industry want to move to the production line, you have this cost who are going up, and the probability of success is critical. The risk of course is going up when you are in this pilot scale, you know, in TRL 4, 5, 6, but the risk open also in the industrial, I will say pre-industrial approach, pre-production. So here it's a good summary of what I said before, what are the critical stage, and I repeat, the value chain is one of the key, I will say, player to win the story. And the pilot, the infrastructure are very crucial to succeed. Thank you.
Thank you very much, Bertrand. I think this was an excellent introduction to the sessions, and I think we skipped the question right now to you, okay. And you will stay, right?
Yeah, I will stay.
So we can have the questions afterwards. And I would like to introduce the chairman of this session, Professor Giorgo Rossi, who is, I think, a very famous guy in the European ecosystem, especially when it comes to, I would say, research infrastructures and the utilization of and connecting the different infrastructures. So I think, to summarize a bit what Bertrand said, I think the whole idea about innovation ecosystems is not only to have them locally, but also to have them connected. And we need to have this connectivity between the different players working together. And I think, Jörg, you have done a tremendous good work of actually bringing all these research infrastructures together. So, but with that, I leave the word to you to continue the discussion here. Thank you.
Thank you very much. If this operates, this yellow thing I have, it's my role now to call the people on stage for the panel discussion. And therefore, Bertrand, je vous en prie de vous asseoir ici. Jörg Hübner from DTU Denmark. He is a PhD in photonics from DTU, who has worked as associate professor at DTU as well as engineering manager in a Silicon Valley startup. He has a comprehensive management education from the Harvard Business School, and since 2009 he's heading DTU Nanolab, the National Center for Nanofabrication and Characterization of Denmark. Thank you for being here with us. Then I would like to call Pieter Telleman from the University of Utwente, the Netherlands, General Director of the MaxIV Institute of Nanotechnology at the University of Utwente. MaxIV is the birthplace of a large number of high-tech spin-off companies. Academic cleanroom infrastructure is there that has become the limiting factor for growth of production for these spin-off companies. And to mitigate this situation, a foundry for small to medium scale production of nanotechnology-based product has been recently initiated with the name New Origin. Pieter is a member of Nanolab, the Netherlands, and which is the Dutch national facility for nanotechnology research, comprising the major national clean rooms in the country. The Nanolab Netherlands facilities are an important link in the innovation process from basic ideas to product. Then I would like to call to Anna Hultin Stigenberg from MaxIV, Sweden. Dr. Anna Stigenberg is a technical director at MaxIV in Lund, which is one of the most brilliant synchrotrons in the world, and it hosts more than 1,000 researchers, users from all over the world every year, engaged in material and life science research. Anna holds a PhD in material science and has a broad background with experience from research institutes. And a main thread in her career has been the interface between research and development, innovation, and the business side. Then I would like to call Gaël Decroix, who is Deputy Director for Research Infrastructure, European and International Affairs at COA Fundamental Research Division. She is coordinator of the Horizon Europe Support Action CSA, called Research Infrastructure Technology Infrastructure for Impact. She was an expert for the Horizon 2020 Program Committee, Research Infrastructures, and has extensive experience in European affairs. And then again, our rich panel includes Thomas Schwann, who is director of MyFab, the Swedish National Research Infrastructure for Micro and Nano Fabrication. MyFab target users who want to create and fabricate new innovative structures, components, materials on the nanometer scale in the distributed cleanroom-based infrastructure. And Yes, we have one more chair for our for our last panelist, who is Amaya Igartua from Techniker, Spain. You will be sitting here. She is a coordinator of the European Actions in Materials in the research institution Techniker and co-secretary of the European Platform of Materials, EUMAT, and the Alliance for Materials. She is member of the core team of AMI 2030 initiative, we heard in these days, and she has been during 10 years the head of the tribology unit in Techniker. She's been participating in more than 50 European projects, and she was coordinator 4 times. And she's authors of many publications on the subjects of this roundtable. So thank you very much for joining us, and I will start addressing some questions, and then we will see how the discussion will pick up, of course, with the contributions of the audience as well. So I have a question for Jörg Hübner, and the question is it crucial that a university-based or university-owned facility covers the full range from basic research to small-scale production, so to pre-competitive production?
Yeah, I think it might be crucial if there is no other paved way to cover the whole value chain. Because if we want to get value creation out of research, there has to be a way all the way through at least small-scale production. And some countries have lined up a way, like in Germany you have Fraunhofer, and in other countries you have other vehicles. In Denmark, for example, we don't necessarily have a way to go all the way to this small-scale production. So if we do research projects, if we participate in research projects concerning micro and nano technology, we kind of lose all the value creation if it stops at TRL 3 or 4. So in Denmark there is no other institution. So in our institution, D2 Nanolab, we have decided, and that was from the beginning, because there was nothing in place in Denmark, that we have to go all the way through from basic research to small-scale production. Otherwise, knowledge and value creation would be impossible.
Okay, so this is important, and this implies that both at the university level, so internal users and as well as external users populate this full value chain that you set up, or you do it in response to user demands, or you do it as proposer of a method?
No, it's a proposed method, and of course it has its disadvantages, because naturally academic and basic research, they want to use the full parameter scale of all equipment, whereas if you have tuned into a process, you don't want anybody to use the full parameter scale of the equipment. There are several, and I can talk long about how we kind of manage that. But I think the most crucial part of managing that is to duplicate some equipment. Mm-hmm. So you have equipment where you limit the parameter range, so it allows consistent processing, and then you have equipment which is more research open and where you allow more experimental stuff. The big benefit of having academic researchers, PhD student, even master and bachelor students working on the same machine than the companies is that the transition from expertise and the hiring and training of engineers is very, very smooth, because we have trained engineers that know the exact machines, that know how to operate in this specific clean room. They can be directly hired by the companies, and our workforce, because training workforce in clean room environment is very expensive, and it takes a very long time. So this gives a competitive advantage to the startup companies and can accelerate the whole process of going through the TRLs by having this trained workforce already from the very beginning. But it, of course, we have to duplicate equipment, and we have to be careful how we manage the clean room facility.
Thank you very much. And just as a follow-up question, I would like to ask to Pieter Telleman, how can we see the bridge between pilot production at academic clean room level to the higher volume production?
Well, we made the horrible mistake. We just had a presentation that showing all the pitfalls and the difficulties that you have as a company to become successful. And we never thought about one of our startups becoming very successful because they have to jump through all these hoops. But now companies have jumped through all the hoops, and they are now increasing commercial production in our clean room. Currently, 50% of the use of our clean room in ours is commercial production. So this is beyond pilot production. This, I would say, is small scale to medium scale production. And you can imagine in an academic clean room where 50% of the usage is commercial production, that is going to present some issues, both with the academic users as well as the industrial users. Which means that we are in trouble. This is why we initiated the thought of a new origin, so a foundry. In the ecosystem, so we want it close by because I still recognize all the advantages of having this in the ecosystem. That's extremely important for the companies, but also for the university. But we need to have a way to increase production and no longer be dependent on the academic clean room. And that, as we initiated this, presents a lot of issues because much of the equipment and activities are subsidized by the government, so there are some issues with state support, etc. But I think it's essential if we look at the developments currently with CHIPS Act that we as universities should also start thinking about what if we are successful. And I think right now we're missing the link between academic clean rooms and full-blown commercial foundries. And that's why we try to fill that gap now with an initiative called New Origin.
But New Origin is a step ahead because, let me simplify, your academic clean room is being invaded by the success of some of your initiatives, and it's really moving to a production scale that will, bring revenues, or it's still another step, but then the full industrialization is to be sought in a different endeavor than academic can hardly.
Well, even to this stage, I mean, we as a university have initiated this initiative. We started it because I think we're in a position to do that. In the end, as soon as we can, we would just like to leave it to the companies that will use it and make sure that they get the right business case, attract the necessary funding, and then commercialize it. And it's a commercial entity, so not under the auspices of the university, because that's not our task. It's not our scope of the university to do this. But we have to start it. We have to be the catalyst to get this started. So that's why we are doing this right now. But as soon as we can, we'll make sure that it's a commercial entity under the management of one or more companies that will use it for their production. And to give you a feel for, because we had a discussion yesterday, what is production? I mean, we're now looking at 1,000 wafer starts per year, and they want to go to 50,000 wafer starts in the next 5 years, which is for an academic clean room quite a thing. So if we cannot make this jump to another way of working, somehow then things stop. I cannot maintain this in our clean room. It breaks down, and that would be extremely disappointing because this is a company that's in existence for 20 years. So it took them 20 years to get to this point and become successful. And now we're running into the next generation of problems. So we're trying to tackle this in the way that I just mentioned with a foundry.
Thank you very much. Now, I have a question for Dr. Stigenberg, and it's a classical question to large-scale facilities. So how MaxIV, as well as the sibling large-scale facilities for fine analysis of matter, actually operates with industry, works with industry, and to the end of enabling innovation from original ideas.
Yeah, thank you for the question. Well, I mean, we see ourselves as a research partner to industry then, and to tackle the challenges, and we have tailored methods and techniques in total in the 16 beamlines, then different experimental stations that are with different methods, so to say then. And also then we are then developing services then that are also then meeting, you can say then, the needs that the industry has, so we can support them in tackling the different challenges. And one thing that is important is, in this case, is for example, how to handle all the data, the experimental data, so visualization of data and to analyze data automatically as much as possible, as one example. Also looking into if we can offer a possibility for the industry to run experiments more or less in parallel in different beamlines also, because they don't have one unique single question. It's more like a complex part of a project. As you talked about earlier also, it's rather complex then if you go from idea to innovation during the pilot scale also then. But I would say that one of the very crucial thing is to have a collaborative approach. That is, I mean, it's not about technology, and so it's quite a lot about collaboration to make things successful. And this means that we have different approaches here then, and one thing is that we for example, then make it possible for the industry to have dedicated resources from their own organization on site, working together with our scientists, and also then, you can say, supporting us in understanding a bit more the application orientation also around experiments then. So we can also further develop methods and technologies to match future needs then. Also then, we have had during a couple of years a successful concept, you can say, then, that the research institutes in Sweden, RISE and Sverim, then they have been able also to have dedicated research on site, a handful, you can say, of persons then working together with the scientists at MaxIV, but also then, and that has been their role, to work together with the industry then to act as a bridge, you can say, then also then to transfer knowledge and awareness of what can be done, so to say, and how to design different experiments then. To meet the needs then. So that is very important then. And to take this one step further also, we have a couple of platforms, you can say, communities that we have built, and together with industry actors and academic actors also, of course, then to enable outreach into different industrial sectors. And one is, for example, with the name Northern Light on Food, it's reaching out in the food industry. We have the tree research reaching out in the forest industry, paper and pulp as an example. We have the metal beams for the metal industry, and also then together with ESS and the Life Science Lab, also then infra-license to reach out in the life science sector. And that is a kind of collaborative approach then, which we found is very successful. Thank you.
Typically, when we analyze the relationship between industry and large-scale facilities that are mostly, let's say, oriented, or at least mostly perceived as dedicated to basic science, we try to define industry as a user, industry as a partner, co-creating new technologies, for example, for the very machines and the very instruments, industry as a supplier of high tech. And in the category industry as a user, often industry does not show up directly so much, but it participates through financing academic projects, paying for PhDs. It's a way to orient the research on issues that industry is interested in, but it's not a way to come out as direct users. So you have the same experience in MaxIV of
So I mean, yes, it's of course that the case that you say. Yeah, of course, the industry also is, let's say, indirectly involved and via the academic partners. We shouldn't forget about that the industry and university partners are collaborating quite a lot, and they take part in academic, so to say, projects which are a bit application oriented, and also then. So that is also very important, of course, then. But we see and we put quite a lot of efforts into having the industry directly involved, coming directly to us also then. And we see also there a growing interest from the industry to do that. And for example, if we look into the last 3 years, if I remember correctly, we have tripled the number of user time from the industry. So it is a growing interest, and but still, of course, we need to put quite a lot of time and effort into creating awareness, showing the possibilities, describe what kind of experiments that can be done, because if you look into the companies, I mean, some of the larger companies, they have quite large R&D organizations and often they have, let's say, they can be on a very high class of the research competence in certain areas then. And so in large companies, you can find, let's say, part of the research organization that understands how they can utilize, for example, MaxIV and other large-scale infrastructures. But smaller companies, for example, and medium-sized, perhaps don't have that competence themselves. So they need also to partner up and have this kind of platform that that I talk about, the collaborative platforms then, so that they can meet other actors like institutes, academia, etc., and also to understand and to bridge over, so they can utilize all the possibilities.
Thank you very much. So I would like to move to a question to Dr. Decroix. You are coordinator of a coordination and support action called Research Infrastructure, Technology Infrastructure for Impact. Can you tell us what's the expected result and what's the rationale of this initiative?
Yeah, it's working. Yeah, so it's a project, it's RETIFI, in fact. It's a research infrastructure, technology infrastructure for impact. As Bertrand has shown you, you see the GRC report, and you see that now the technology infrastructure become more important. We had some, for instance, you have the European Commission had defined a specific action in the European research area action. It's action 12, and you have at policy level, European Commission looks at technology infrastructures. And the idea with the CSF, with the coordination and support action, is to have a look on the technology infrastructure, but also on the research infrastructure, and to see the difference, but also the synergy between the both research infrastructure. In fact, they are not opposed. If you look at it, it's important to, and you know that probably that the research infrastructure is also important to remain at the forefront of research for industry, and also but to test and to reduce the risk of new technology, or to develop the technological know-how, and to probably to short the time to market. The technology infrastructure are probably more appropriate than the research infrastructure. And through the CSA, the idea is to at least to define what is the concept of technology infrastructure, because you see it's a OETB, it's a pilot line, it's a digital innovation hub, so you have so different purpose for technology infrastructures, and it's not so easy to define what is in fact technology infrastructures. But after this concept, the idea is to compare, to look at it at the difference between research and technology in terms of business model, in terms of user needs, and user needs from research and technology infrastructure, but also needs of users. Both have industrial and researcher, and also to look at the different parts. And at the end, as an example of what have been done, and Giorgio, you know it, at S3 level, you know probably the S3 roadmap. And it was the idea was to define a European strategy for research infrastructure. And the idea to have also probably a European strategy for technology infrastructures. But as you know, it's not comparable because it's a question is quite different because the industry are part of this strategy, and we have to look also on industry needs. So we will build some recommendation based on case study. We have pre-selected the 5 area, and based on this case study and this survey, we want to address some recommendation to enhance, to increase the visibility of technology infrastructure, but also to have a common approach based on research and technology infrastructures.
Thank you very much. So yes, this is definitely important because we see a continuum. I mean, philosophically, is a continuum from the fundamental research to the production of things that we have learned how to do. I mean, from fundamental research, we get new knowledge, and then the way to develop a new know-how is the part that sometimes is not directly doesn't concern so much the scientist, the academic scientist who seeks for the new knowledge, but the know-how is based on the knowledge, but is also based on the demand, because it's the other end, and the other end we heard this morning can be the military, can be some big projects, can be a single industry having a vision. So this in between might qualify the concept of some infrastructure to help the technology transfer, so to say. So thanks for this, and I would like to ask to Thomas Schwann about MaxIV. So this is an infrastructure where the users fabricate or synthesize what they need. And how does it work, the access model for users and the operation, and what are the ingredients of the success of MaxIV?
Yeah, thank you. I'm Thomas Swan, and I'm representing MaxIV. MaxIV is a national research infrastructure in Sweden. We have labs here in Lund, also at KTH Uppsala, and at Chalmers in Gothenburg. And I think we are kind of similar, I would say, to the infrastructures presented already by Jörg and Pieter here, because they're based on academic clean room laboratories. But speaking for MaxIV, we have actually a very open environment where we have typically more than 800 users, 835 last year, from both academy and from more than 100 companies actually. And what makes it attractive? And I think the title of this session is really From Ideas to Innovation. And we all want to promote innovation and bridging the valley of death, of course. But just to say something on the starting point, we have tried then to make this as a very easy access infrastructure where you lower the thresholds to come in. We have, of course, education, and we have a very open method where you can book essentially without no waiting, lots of instruments. Typically, the knowledge on how to use instruments, either you get them from your research department or you have built up the skills in a company. But we also provide teaching and education, of course. Then, when you fabricate something, this is, of course, then a lot of research projects, but in many cases we have production. We have a couple of examples like Ironova and Low Noise Factory really have their production of key components in MyFab. So the challenge is, of course, to be both flexible and provide some kind of reliable environment where you really can produce. And I think to be active in the same environment, we learn a lot from each other and from the demands that we say that you have to think of the industrialization from the beginning. And actually, I think researchers will be more aware of the needs of the companies. Still, we do have a problem to bridge the valley of death. In some cases, companies, of course, are successful. But what we try to do then is to level ourselves up in some kind of knowledge value chain. Typically, when you have been using a clean room environment, you know what to do, and maybe you have 10 to 30 processing steps, and that's the knowledge built up by the researchers. Now we try to define and understand what is a process, a fabrication process. Or maybe then you could say it's a pilot line or a very flexible pilot line already in this kind of environment. And we have actually a lot of networking activities going on to see where we can do and also to transfer such knowledge. So by having a very low threshold to use the environment, to be quite tolerant, we accept a lot of initiatives to change processes actually within limits. I think that has been a success and made it attractive.
Thank you very much. I think we will come back on that, but I would like to ask to Amaya Gartua about you work and operate in this facility that has an open innovation test bed for tribological characterization of the materials. And so this is a open access facility, and how much of the material development intercepts and why it's so important?
I can try to explain a little bit the model of working in this open innovation testbed. It has been an European project that has been performed for the European Commission, but this project has came to the end. And we use, before finishing the project, we use user case studies in order to carry out the tribological test and the modeling to do the tribological test to different users. And now is the position that finished the European project, and then we have created a company. As Techniker, we have experience of creating 32 companies already, and but this is a special company in which the business model that we see is that up to now we carry out tribological tests mainly for Spain. Then in this European Tribology Center, that is the name of the eTribomat Open Innovation Testbed, the idea is to make tests for all Europe. And then we are combining testing infrastructure of 100 tribometers all over from 5 research centers in Europe, and combining the expertise of 250 experts. Then the idea is that when a company from Europe needs, or could be after also outside Europe, but less limited now in Europe, needs a tribological test in order to measure the friction aware of a certain component or process. Then you need to know what could be the consume of energy of a certain component, and you need to know a material if it could be good or not for such a component. Then it's possible to make a modeling of what is the way to work of this component, a model in order to transfer the testing condition at the lab scale and do it an accelerated test as the lab condition in order to evaluate the friction, the energy consumed, the wear, the durability of the component, and then to translate to the field, there's first field to lab in order to test the condition. After you make the test, and after you have to translate from lab to field, and then you require more in order to translate what could be the effect on the system. And with that approach, what we try to do is improve the energy efficiency of products during use and process, and also to increase the durability of materials that will help circular economy. And how is the business model? Then it will be an application. One is user, that one company can make the inscription in eTribomat open company, eTribomat website, and can make an offer or a request of what they need. Then it is find what could be the best test bench to be used and the best expert to attend to the offer, and is make the offer to the company, and then it is establish a interaction with the company in order to give the service and to have a similar service from different providers. We carry out round robin tests in order to be carried out by experts. And this is the business model that the company has 1 month lifetime. Then we have to demonstrate that this investment the European Commission has done on open innovation testbed can become a reality. Then we have a lot of responsibility in terms of facilitating the pathway from the lab stage to the real industry application side.
Thank you very much. So let me ask a question that concerns what you just presented, but also the other in general, the academic infrastructure that is trying to move to the higher TRLs and intercept possible industrial application. Is certification an issue? Because I know it's hard to deal with that from the academic side, and how do you go about ISO 9000 or whatever? Because sometimes the industry may require that before buying some knowledge from. Okay.
Yeah, in our case, we have ISO standard in order to carry out the test, and is also requested for providers of that, and is part of the pre-screening of the lab. Is a must for industry. If you like to give an industry a service, is a must.
You were
yes,
nodding.
Both yes and no. We do to some extent have ISO certification within our infrastructure. KTH, for instance, has that, and of course, I think it alleviates skills is important, but I don't feel it's really a showstopper either if you don't have it.
Please.
Yeah, I think it's a two-sided thing, because everybody likes a working process. Also, the academic world likes working processes. Once processes are established, and if you do a micro device, you have maybe 20, 30 processes, if and then you tweak maybe 2 or 3 of them. If the other 27 work and are kind of standardized, everybody is happy. But then there are the 3 processes that are not standardized and that you want to tweak and work with. So it's a mixture. What we do, we are also ISO 9001 certified. What we do, we have certain equipment that we dedicate for research. Mm-hmm. So there's the suite of equipment that you can do all the processing, and then we have maybe duplicated again a piece of equipment which is not part of the ISO certification, where research is free to do and to change and to modify and to tweak, and that then once maybe there's new processes and new functionality established, it might also move into the ISO chain, and then we have another tool that is dedicated to research. So I think it's important to cater both the academic world, where there's a lot of freedom, and otherwise also the industrial world, and then not to forget that the academic world also appreciates certified equipment for their standard processes. So I think there's an advantage for both in the end.
Others want to comment? Yes.
I guess we're notching towards certification, ISO certification 9001 2015 these days, as kind of an insurance policy. As we now have so many different users with different aims and activities in the clean room, you quickly get a discussion about, is this equipment doing what it's supposed to do, especially from a company side of things. So we are now in a situation where we validate instruments for a particular process, and that is checked. So when a piece of equipment is down or something is replaced, we make sure that it adheres to that particular set of values, and then we know it's working. If somebody uses it for a particular different process, it's their problem. So they have to make sure that it works according to their particular sets of demands. But they cannot come back to us and say it's not working the way it should be, and that's why we validate our machines now. And as far as possible, for some machines that's more easy than for others, but that is slowly nudging us towards writing everything up and making sure that we have kind of an insurance policy to show the people that the machine is doing what it's supposed to do for that particular process, and the rest is your problem. So I think ISO certification is getting more important. And we have medical instruments or chips for medical equipment that is being made in our academic clean room that is actually certified to be used for human purposes. So it is possible also in an academic environment to even adhere to those very strict standards.
You wanted to say, Bertrand?
I didn't explain this, but I think for the future, if we want to have a stronger European sovereignty, it's very important to manage and to lead this certification. That's crucial. And whatever the step in the value chain, when you have the material, you need to control what is the material. When you are in the process, you need to control which process and so on. And it's very important to keep this in our different step of the process for the product. We need to control this certification, whatever the step, to be sure and it will be more and more important because the sustainability will bring us how to use recycling material and so on. So we'll use second life of material. So we need to control this, and certification is a good way to control. Yeah.
Please.
Maybe I can add that in the end, ISO 9001 is a way to learn from your mistakes.
Yeah.
So, and it's a controlled way to learn from your mistakes. And the other part of ISO, especially the newest, the 2015, is about risk management also. And risk management is important if you have industry in your facility, but it's equally important for PhD students that have 3 years to do their PhD. So again, it is a nice occasion to take up what you have done and to learn from your mistakes, and you should do that anyway. So the initial part, to come to the to write your procedures down and so on, it's quite a chunk of work. But once you have it done and it's a rolling process, one shouldn't be afraid of ISO 9001 because it's something that you're supposed to do anyway.
Now I have a question to all of you, and particularly those who are managing the academic and advanced clean rooms. So your users or customers, I don't know what you like to call them, let's say users, may attempt to develop a product. And in doing that, they develop some process, some protocols. And maybe the end product doesn't work, so the project has not led to a winning end product, but several steps on the way have a knowledge content that is important and is enriching the facility and the community. So the question is, how do you see the fair data principles applicable to fair data sets on protocols that once established, they could become, you know, with all the protection of IPR or whatever barriers, but they could become shared knowledge, and the next attempt to do a different product will take full stock and advantage of what has been learned using public infrastructures. Please.
I have a comment on that, and actually we are working towards a structure to take care of those issues. And of course, companies that might want to keep their secrets, they should be able to do that. Although it is an open environment, so they have to take some care when they work in the lab. But if you develop a process, you own the right to decide yourself whether this is a public knowledge or if it's something you want to patent or so. And we also try to implement support in our booking system for handling different kinds of processes. Although we are not done with the work yet, we can think of at least 3 levels. One is the completely open access, and that is really good in case we see very often that, for instance, PhD students, they develop something new, and they leave and they go on a postdoc and they know what they've done, but the infrastructure they used to belong to lost some of the competences. So try to keep that and make it available for free then, normally. Or it could also be something you protect by yourself. We could also think of something in between. We don't know exactly how to make it, but maybe that you could charge people to use, or you make it available to a limited set of people. So I think it's a very good question. It's very relevant, especially I think to define and understand what is a process. And if we can then in networks have actually processes that demand key instruments or key techniques elsewhere, you have to take care of you don't want you should be able to transfer wafers and maybe do some kind of remote processing in the future.
Mm-hmm. Yes.
It's a complicated issue because on one hand you want to build a process expertise database, so you can have companies starting at a relatively high level with advanced processes. On the other hand, of course, there should be the possibility to keep things secret, at least a certain point in time. And then there is the issue with having maybe relatively standard processes, or for some people standard processes. A trivial example would be deposit 5 nanometers of gold on silicon dioxide with some adhesion layers. somebody would claim it's my process. I have developed it, but it's a generic process that everybody has to use. So how can that be handled so you don't block part of your user away from what you're doing. What we have done in our general contract is that people have the right to the processes they have developed. If it's under commercial conditions, under the academic conditions, they have to give it for free at some point when they have published. But we at the D2 Nanolab have always the right to redevelop a process. Mm-hmm. So that nobody can block the facility from by a proprietary process from doing generic work. So and of course it's not as clear as it may sound, but there is it's a very difficult issue actually.
Because I think this is very important if you operate a distributed infrastructure. Because in a distributed infrastructure, you want a well-established process to be doable in the other node of the infrastructure. So just make a simple example. We have a post-laser deposition facility, and we are exploring all sorts of metal oxides, quantum materials, topological materials, because we are very close to the fundamental research. But every growth, once it's well established, is described, all the metadata are there, and it's reproducible at another node. We have 22 partners of the infrastructure in Spain or in Germany, and the users can have and take home if they have a PLD at home. So yes, you have a comment.
I think you touch upon a very important thing here. We are not, we don't have a perfectly good model to describe a process at all today. And when it comes to fair data, we are engaged within the Nanolab and also in the Nordic network in the project. How do we really describe process in the same way so we can understand each other? And that's an important step by itself. Then also adding to the previous question, in Sweden we have something called lärarundantaget, which means that teachers, they have the right for their own inventions if you're employed at a university. And that is a very good thing if you're a Swedish researcher, but it could also mean that you have to handle those differences when you collaborate with people abroad or in a network.
Please.
It is very fuzzy because in all our clean rooms, I guess the academic users are mingling with the industrial users. There is no distinguished user. I mean, maybe they have a different gown on, a different color gown, but otherwise they talk to each other like colleagues. So nobody's working isolated in a clean room and thinks up something just out of the blue, completely new, without being influenced by other people in the clean room. So that makes it very hard to kind of assign IP or any intellectual property rights to a particular idea, because I think it's always, it's sprouted from an ecosystem where you have 30 years of development, and they will benefit from that 30 years of development. So it's very hard to say, this is mine. Nevertheless, we do allow companies to have their own let's say, administrative system where they keep track of their processes and process development. It's one additional reason to go to a foundry, because then it becomes more separated, because in the foundry currently we're working with, they will own the IP for all the processes. And we can transfer as a university information to that foundry after negotiations and after particular conditions. So that would help also in kind of pulling these two apart. In addition, I can mention it's a little bit outside of, in the Netherlands, we have 5 major clean rooms, and recently we all transferred to the same management system. So we now can see into each other's kitchen, we can share processes, we can look at which apparatus they have in the different nodes. We are on our way to sharing infrastructure as well as parts that we may need. So we'll have them localized centrally in the country. Instead of every node having spare parts, we will centralize this. Mm-hmm. So I guess also for those countries that have multiple clean rooms, it's been extremely helpful. I would even call it a virtual nanolab now in the Netherlands. It's also helpful to communicate to politicians that why we have 5 clean rooms. That's a discussion that we had, and politicians just said, why not just build one in the middle of the country and have no more discussion? And we all know that you need an ecosystem. So every node, every clean room has an ecosystem, which is very hard to replicate somewhere else on this planet. But sharing information, having the same software helps tremendously. So I would also advocate that if you have MUFEB or any country where you have multiple clean rooms, academic clean rooms, to tie them together with the management system that is the same.
That's absolutely true, because at the end, something that is very important for scientists, but I think it's even more important from an application side, is reproducibility. So you can have demonstrated that you have something that you did very well, but without describing all the conditions, and then somewhere else it doesn't work, and then the whole thing collapses, or anyhow takes more time to reconvince that it was so good what you did. And so this is, I think it's an important alignment problem that you are addressing, as you said, with the common management, but really description of processes, metadata, and the barrier of publicity you decide. If the technology of the metadata set is adopted, and if the EOSC starts working, that doesn't mean that you are obliged to open as possible, and is as restricted as necessary or as wished. Of course, we have barriers with the health domain. There are GDPR, there are other barriers, but also in the industrial, I think. But these barriers may change in time. And so if the technology of the data set is there, at one point you say, well, I can lower this barrier, make it more public because it's not as strategic or as new, or I have used it, then you can do, and then it's immediate advantage for the scientific and technological community. Otherwise, the reproducibility issue is important. And just let me ask if you have comments on reproducibility problems when you try to develop, very advanced processes.
Well, imagine that you have a clean room where you as a company do your production, and at the same time bachelor students that are in the clean room for the first time in their life just concluded a course of a couple of weeks, and they use the same equipment that you do for your production. Basically, everybody wants reproducibility. Academic users want reproducibility, industrial users want reproducibility, because in the end everybody wants a working chip. The thing is, if you're not in a situation where you can duplicate equipment and design it for particular use, commercial or non-commercial, different customers, different users will use the same machine, and that will always lead to issues with reproducibility. I guess in Utwente we have a fairly strict management regime that we do not allow certain materials in certain ovens or to avoid that. But in the end, having the mix of academic and industrial users will yield problems with reproducibility.
In our case, that we are comparing different materials, of course, what additionally to the round robin test, what we do is, in order to say that one material have certain properties that are better than another material, to analyze the standard deviation of the test that we are carrying out, and the difference will be bigger than 2 times the deviation standard of the testing, in order to check that is that the difference between 2 materials is not significant, and with this reference it's possible like to establish the ranking of which material will be better for one application. And we try to use this together with calibration of the machines with a reference that are always done in order to keep, and these practical guidelines that we use, this can be shared.
Please.
has normally in clean rooms like ours two main causes. One is the multi-user environment with different processes on the same machine. The other one is the same reproducibility issue that that big production company have, is the process window. Because you have to establish a process window, and if you're in the middle of the process window, you have good reproducibility. If your process window is small or you are at the border, you have low reproducibility. Doesn't matter how the machine otherwise is used, your process window too small or you're at the border, your reproducibility is compromised. Now, startup companies normally, at least that's in our experience, maybe it's better for you guys, but our startup companies, they don't take the time, because in the semiconductor industry, they say it takes a few weeks to establish a process. It takes many months to establish the process window. So our startup companies normally don't take the time to establish a process window. So when we face reproducibility problems, it's in a way they kind of push it over to us and say we have reproducibility, do something, and then we have to find out, is it the multi-user environment that causes that, or is it the process window of the process that the company is using? And that's not always a trivial task to do, but it is again more complicated than just pushing everything on the multi-user environment, because they don't have time to establish a proper process window often.
Please.
And this is why I think we need to differentiate between the pre-production and the pilot. And to open the door to everybody, it could be the beginning of the nightmare. And this is why it's important to know when we move towards the industry. That means now it's not to do trials. Our industry is doing trials. I used to work in industry, not in electronics and so on. But when you are doing a trials in the plant, of course you stop the production and you do your pre-production of new product and so on. But you need to clean up everything to be sure you will do a test in the real life. And when it's done, you need to clean up to be sure you start in the green, in the clear environment to restart the production. And it's well known, industry don't like to stop when they produce to make tests. If you used to work in research in industry, when you arrive to knock the door and say, oh guys, we have a very interesting stuff, we need to make some pre-production to know if it's work. Oh yeah, we have time. No, we have production to do. And they don't like to do it because we disturb the production. And this is why pilot is crucial. And of course, a pilot line is expensive. But in Europe, we have enough strength to share our facility, our pilot, to focus them on test pilot and to less our production to produce. I think that's the way we need to work. To use our, I will say, network of pilot line, whatever the business, electronics or packaging or energy, whatever, to do the pilot. And when I say pilot, it's not a small machine. It's a kind of a pre-production machine. Of course, it's very expensive, but we have enough strength in Europe to build up this, I will say, this army of pilot line, to be sure we will face the world competition, That's the way. In other way, you will waste always time for the industry, for the production, because production start, wow, nightmare, what they did before. We are not anymore in a good condition. So that's very important to prepare this and to have a good landscape of pilot and production, and to work, as I said before, as a team in the value chain, team between this research, infrastructure, technology infrastructure together. It's a European team we need to build up.
Okay, if I take some messages from this roundtable, let me try to formulate the following. Academic clean rooms, when they move towards or they serve some users that are more application oriented or pre-production or developing a product, they may differentiate the instrumentation. They may dedicate part to that end and keep a broader, maybe certify that and keep a broader usage of the instrumentation, putting it to the limit, as Body said, for the more academic part. So somehow narrowing in the direction of industrial or pre-industrial development. Now we speak of technological infrastructure or pilot lines, and I see two aspects. One is that, as it was just mentioned, the pilot line avoids the industry to stop the production plant and simulates somehow how the real production plant could work with a process that is compatible.
Yeah.
Okay. So this is one aspect. So I understand that if a group or a company or a user of an academic clean room develops something maybe very original that could fit eventually into CMOS technology, that is clear innovation, because it will go back as an additional improvement of something that exists, that we know how to do, and that has a huge investment on the industrial side. But the academic end of the academic infrastructures is motivated by the so-called disruptive innovation. And disruptive innovation, by definition, does not have to be compatible with something that is not there. And so, in this case, what is the pilot line? So the technological infrastructure that you are describing is a facilitator for improving industrial processes. Let me narrow down to this. Or is also, or is mostly, something to carry on to a higher level that might convince big investments from the outside. Well, we heard this morning something that we have to cope with. China, United States, they have a big resource that is the military expenditure. With the military expenditure, you justify anything. You can put huge amounts of money and you can support, you know, even Star Wars, we remember when we were younger. Europe does not have that for the moment. So disruptive innovation may go to a dead end at some point when huge investments would be required because it's not compatible with the business as usual. So I don't know if this question makes sense to you and if you have reactions to that.
I mean, you're right. It is very difficult, and specifically with clean room and infrastructure, it's extremely expensive. It's expensive to build the building with all the criteria. It's expensive to buy the equipment, and it's expensive to operate such a facility. Is one of the reasons that many of the SMEs are using academic clean rooms, because they simply don't have the means to build their own or have their own facilities, which is problem number one. That also leads to the next situation. If you're successful, at what point can you have your own facilities? And the initial investments are so large that you really need a major turnover to be allowed to have your own facility. We actually have one now company in Twente, which after 30 years is ready to go greenfield and build their own clean room. So that's after 30 years they can make that investment. With our initiative to start this foundry, we have a stepwise approach. So we took a 6 million loan to get started. So that will allow us to buy equipment, which we will still put in our current academic clean room, but it is duplicating existing equipment. So we get a separate process line, which is not used for academics, but purely for production. And we're now trying to find the necessary square meters where we can expand this, this process line and have a completely separate process line. And then we're looking at an investment of an additional probably around 100 million euros. And then we're trying to find a suitable venture capital or insurance company that will help us with this. So that's the current struggle. But we're taking a stepwise approach, and we have seen that people recognize the problem, especially the current situation where Europe has said we need to be less dependent on certain countries. So something needs to happen. So when we initiated this thought of a foundry, we got a lot of response from politicians on provincial level, municipal level, national level, because they understand this. It's easy to explain. So I'm quite confident that given enough time, we'll get there. But it's not easy. It's very expensive. But we'll get there.
Bertrand?
So if you remember the curve I showed this morning,
Yes.
you know, about this funding, we are typically here. If it's disruptive, that's the big nightmare in this middle. How to link, to jump from this fundamental or this lab scale approach with this moment where you say, okay, let's move towards the pilot first, because pilot, you are obliged to go to pilot if you are disruptive. And who will pay? It's the industry, it's the policy. That's the key question. Where you are in a, I will say, incremental approach, it's different, because you could find you need to upgrade the pilot, so it's an easier game to find the money. But when you are disruptive, that's the tricky part of the game. And in Europe today, we miss these people who put the money on the table. In US, they have the guy who puts the money on the table. And in Europe, we miss this. Of course, we have different kind of approach with the EIC, EIT, you know, all this. But it's not enough, I think. We need to change, to think differently. Because if we have a real disruptive approach, it's a lot of money. And I don't know, I have not the clue today, but we need to think what could be the methodology, the approach to solve this. Because I'm sure today we have a lot of disruptive ideas who are stuck, and we need to solve this.
We had a case of actually a Swedish company in our clean room running a pilot line, and then they couldn't get investors from Europe, so they had American investors and were moved to Silicon Valley. So that's because we're missing the risk welcoming venture capital in Europe compared to the States. There is still a difference in willingness of taking risks in Europe, and that's a problem for that because it's so capital intensive, the business area we are in.
Gael.
Okay. Yeah, probably the funding, it's a crucial question for technology infrastructure, because when you look at the research infrastructure we have some investment of public authority, in fact, but for technology infrastructures it's quite different. But also because probably it's also a question of industry. We have to develop, so it's domain by domain, and it's also a question of economic questions, also how to be question of competition for research. Probably the approach of the state, of the public authority, is quite different. But in fact, we have this question is on the table, I think, because we, as you explained, we need investments, and it's very important to have a collective approach, in fact, at European level, I think.
I have a reflection here. I think we have too few medium-sized companies that are willing to have a portfolio of different kinds of development projects. It seems to me that in Europe and Sweden especially, we have quite a number of SMEs doing pretty well, and we have some really major international companies. Earlier, I was working in a mid-sized telecom company where we have the possibility then to be more like an SME in the way we could try some disruptive technologies and sort of high risk, high possibility projects in parallel, that we had some more step-by-step incremental improvements of existing products that could, we were doing well business-wise, so we were aware that we could or have to stop some of the projects which didn't work out. And that was typically trying to bridge the valley of death by new product development steps. And so I don't know if there is a model or if there is a way to promote or help medium-sized companies that can have such a mixed portfolio of projects. It's rather a question than an answer.
Of course, if questions arise from, I see Marcel first, please.
There are so many sessions here, so I went from one to the other, but the main time I spent here. The big problem in respect to of financing on one side, from research, fundamental ideas, into fabrication, production. If I look a little bit about what is going on in Asia, for example, at Tokyo University and the Tokyo Technical University, but also in Tsinghua in Beijing. There are some conditions that the inventors who has invented the idea, who did a lot of research and development work, that they also become, or they are forced to become, the manager in industry, that he and his group, few people, are transferred or taking the responsibility in the industry. So that means the transfer goes from talents in fundamental research and invention to the fabrication. So, and the industry and the government in particularly supports that about funding, but the industry is also interested in these models in order to get a smooth transfer, as it is quite difficult to tell to the industry is that it's far away from the research to tell exactly what he has to do, because it is in the blood from the inventor, and it is very difficult to transfer his blood in that blood from the industrial. And I think one should think in Europe such kind of systems. Here it is again European Union. We don't have the United States of Europe, one Europe. We have 28 European countries, and it might be more difficult, but I think it is quite a good system, and which is quite successful and quite strongly motivated. Professors can keep their position as professor, but he has also the main duty with a few people of his group to be transferred into the so-called pilot and also in the industrial aspect. I think an idea which one should reflect on, Chairman. Thank you.
Thank you for the suggestion. Let's collect another question there.
Hello, thank you very much. I had a question regarding the success stories. I'm Miriam from INL, sorry. And I had a question regarding the success companies that you mentioned that are now even building their own clean room. Do they give back to you the clean room that helped them reach success? It's a bit similar to what the Kicks are now trying to do, like the payback. Just wondering if this is ever thought of.
There has been IP where the university owned a portion of, and that was made to cash, and that went to the university. So I guess in that sense they're paying back. They also contribute with co-financing of projects, right? I guess in most cases you need at least 50% co-financing for almost all projects these days. So we're knocking on the doors of all companies to get that kind of co-financing. So I guess in that sense that there is an exchange of funds, and they are part of the ecosystem where you together with all these startup companies and existing companies together try to achieve projects. But the major income for the university has been selling IP off at some point.
Yeah, I'm Stijn Goossens, the CTO of Curve, and I would like to speak here a bit as a customer of academic facilities. We are a spin-off of a research institute that has a clean room that we use very intensively, but also around we have been using other facilities. And so one of the issues that was mentioned was the process control. We clearly agree with that there's a mismatch between academic and industrial needs. But another thing is the mission of an academic clean room and the mission of the industrial user. Well, one of the key pillars is also education of the users. And what means education? It means making mistakes. And when you make a mistake in the clean room, that means quite often that the tool goes down for a few weeks, a few months. And I think the main pain point in us using academic facilities was the long downtime. And so I would like to ask what are in your cases best practices to deal with that pain point.
Take the last question first. Downtime is always happening. We have more than 700 instruments, so obviously there could be some problems someplace. But I think to learn how to work in a clean room environment, to educate people doesn't mean that you have to stop the processing. You have to, of course, know what parameters you could manipulate or what's allowed to do in the clean room. And I don't think we have so many errors caused by that. But the importance of education is not so much discussed today. Last year we actually checked how many users, we have a lot of users, we know, but how many are new users that didn't come there last year. And in MiFab we have 835 last year, about 1/3 are new that particular year. So there's a flow of people from different levels using the clean room, many of them PhD students. So it serves as a very important source to educate people that go further to industry or to other academic institutions. And that's a very important number. We were not aware of it, actually, before checking.
Please.
Yeah, concerning your last question, we have actually a category in our quality management system, which is called a USEP. A user cost equipment breakdown. So we're tracking these mistakes, as you call it, and then we adjust the training so that the same mistake doesn't happen. And actually, if you look at it, now we have statistics on USEPs for 10 years, and if you look at it, it's a minor cause of equipment breakdown. Is actually that USEP. I would guess it's in the order of between 10 and 20% max, so more 10 than 20% of the equipment breakdown is directly user cost. And of course, if you adjust your training and to do a little bit, then you can push that further down.
Sorry, hello, Anna Stenstam. I just wanted to comment on the downtime. I mean, no matter what the reason is for the downtime. I mean, isn't one of the things about us meeting here and the thing with MiFab, for example, having several clean rooms in one network and expanding this to Europe, that we can maybe try to help the users by dealing with it together? I mean, some of the things are actually possible to do in another place. We will have a significant downtime when Nano Lund lab is moving.
Yes.
I mean, that's going to be down for a long time. So in that time, we need to help each other so that we don't, so that you and others do not experience this too painfully. I think that's really, really crucial. So I just wanted to make that comment, no matter what the reason for the downtime is.
Sure, sure. That's why in a distributed infrastructure, we need redundancy of instruments and facilities, not to jeopardize the user projects because of maintenance or whatever, or breakdowns. You have a comment?
Collaboration is extremely important. I mean, yes, we also have breakdowns, and especially in this day and age, if you need a spare part, it can take months, even up to 6 months sometimes. So then we call Jörg and we say, do you have a spare part somewhere in your cellar that we can use? And somebody drives off to Lungu and takes it back home, and that is pretty much for, well, Belgium, the Netherlands, Germany close by. So I think in that sense we can mitigate some of the issues that we're confronted with.
Okay, let me ask for a last round of comments on the following. Gathering from all what we heard and thinking of this possible perspective of pilot or technology infrastructures, how much today of the demand by industry or SMEs who address academic clean rooms is for the extreme capability of the clean room, or it's more for standards? So how many people really ask for few nanometers lithographies and very advanced characterization, or how much of the SME work is rather less extreme, and therefore we could think that to help them, technology infrastructure will not compete with the research infrastructures because they address a different community. Please.
I think what very often happens is that that you have a process flow of 20, 30 processes, but one of these processes is cutting edge. So and the rest is pretty much standard. And there comes the disruption, and there comes the competitive edge, because otherwise everybody could just think about it and do it. But in every clean room we have some area of expertise or some kind of tool that there is a world champion expert, and that kind of brings the whole, makes a new device possible. And so often, but of course not always, often you have standard processes, bread and butter, and then there's one thing sticking out that makes the whole thing competitive compared to elsewhere. So that's
as well. One of the major growth areas right now is integrated photonics, and in our world that is silicon nitride waveguides, which is a process that existed for 15 years, maybe even longer. But they're still optimizing to get the lowest loss possible, because they now have applications in quantum photonics, where you want to hang on to every photon that sits in your structure. So that means even now we're optimizing the etching of these waveguides that you get nice straight edges, so there's as little loss as possible. And then you're really starting to touch upon what Jörg also refers to, that etching process then becomes critical. Whereas as etching is fairly straightforward. I mean, we've been doing that for decades. But for this particular application, you're looking then at getting it as good as possible.
Thank you. Please.
I can fill in here. And it's very important to see that we have different kinds of infrastructure, research infrastructure. When we fabricate something, typically you have a lot of steps, and that gives us the opportunity to make a good planning, actually. And a lot of things can happen in parallel. And through our booking system, we see very well where we have maybe some bottlenecks, and that is of course a very good motivation to reinvest and to increase the capacity. And infrastructures are opened basically 24/7. So with the planning, you could avoid a lot of waiting, and you can schedule, and you can have things in different phases actually in the clean room. So I think we can handle that pretty well. Then, of course, as Anna brought up here, redundancy is really important. And I would say in most cases, we have the possibility to redirect the needs to other parts of the infrastructure, other clean rooms. And that's important. And then we also, this could be done on a very short notice, of course, since we can just travel and book.
Thank you. I think there will be ground for continuing the discussion because it was interesting, but I would like to ask for last questions or comments, if any, from the audience. And if not, I would like to thank warmly all the panel for this session.